Hi, everybody. Welcome. Thanks for coming. This is my talk on Conda-press, or Reinventing the Wheel. I work at Quandsite, so if you haven't heard of us, you can find us online or you can talk to me afterwards. So just a couple of ground rules about this talk. I have given you a text color that this is the minimum places in the talk that prompts you to say something. You are more than welcome to interject at any other point in time and hassle me however you want, but the green is at a minimum. Okay? Everyone understand?
Who are you?
Yes. Who am I? Oh, I'm Anthony Scopatz. It's right there, so you can find that. Yeah, sorry, in case anyone was confused. Okay, so that's the ground rule. So please, yeah, interject. Second part. Press is a pun. Maybe we'll talk about that later on in the talk, but I'm not going to reveal what the pun is right now. Okay, so what are we even doing here? So Conda-press is a new tool that lets you take Conda packages and turn them into Python wheels.
What?
Yeah, like why? So this talk is going to talk about why in the world you would want to do such a terrible thing, right? It sounds truly awful. It's going to demonstrate that we actually can do such a terrible thing, which is also awful. Just making the world a worse place day by day. And then we're going to dive into how such a terrible thing is done. And then we're going to talk about some safety precautions when doing such a terrible thing, right? Because we want everybody to be safe. So.
This can't possibly work.
I agree. Also, I forgot to mention one of the other ground rules. There's going to be a lot of just excessive animations in this talk, so get used to them. All right, so this can't possibly work. So let's go ahead. We've made a little terminal here in our space. We've got a temporary directory, Conda-press temporary, and I'm going to show you that this tool actually works. So I've got a lot of completed commands here, but we're going to start with time, Conda-press. Let's skip out of some of these things. So we're going to keep right up here at the top. Nope, we're going to just do don't strip symbols to make it a little faster, and subdir. Linux 64, and we're going to build a wheel for NumPy right now. Right, I need to activate my environment. Okay, let's activate the environment. And then we're going to go ahead and run Conda-press, and it's going to run for a little while, and we'll come back to it in a moment, but it's going to go ahead and download the Conda package and start turning it into a wheel. It'll actually go back up. It'll walk the whole tree, the dependency tree, and create wheels for all of the little things in the dependency tree. And so right now you see libopenblas is working. It's grabbing curses and a bunch of other stuff. So this is going to take a moment. We'll talk about why also in a moment. Hey, Aaron, how's it going? Hey, Mike. Oh, yeah, sorry. I added animations to remind myself when to go into shell. All right. This is Conch, by the way. So if you haven't heard of Conch, that's a different talk, but we can also talk about it here if we want. Okay, so the postulates. What are the postulates of this talk? The first one is that building software is hard. Anyone agree or disagree? Yeah, there we go. Thank you. All right, the second is that luckily, luckily, Conda-forge is a huge community of about 1,500 people dedicated to building software, normally in this PyData stack. So unfortunately, some people want to be able to pip install packages on every freaking platform. So what do we mean by that? We mean Mac, Linux, Windows, ARM, PowerPC, just everything, right? And getting native packages for those architectures is actually very difficult. It's super difficult once you hit a C extension. which I think we can hopefully all agree upon. But Conda-Forge builds on all of those platforms, and so a lot of the hard work of building packages has already been done. So like, why would we go and build wheels from nothing again if we already have all the hard work? So what we should just be able to like take the Conda-Forge packages and press them into a more circular shape, i.e. a wheel. Okay, so what did this do? So this took about a minute to create our NumPy package. So if you look at this, what is it? There's a bunch of different wheels, including the whole stack. Right? It includes your C runtimes. It includes Python itself. It includes TK and zlib and all this other junk. And wow, that's just a lot and kind of crazy. And so, oh, sorry, I skipped to that a little early. But let's go back to what the vision of Conda-press is, okay? So to orient ourselves a bit. All right, so first things first, package XYZ is released, or package version XYZ is released. Conda-Forge goes out and builds that version, right? Like this is just something that happens. Conda-Forge, in our vision statement, Conda-Forge will then also go out and build the wheel for you. And then, after the wheel is built, it will publish that wheel back to PyPI. And then finally, everything is awesome and we can go home and rest on our laurels, right? So then we would have wheels for all these different architectures and everything. So what did that command do? Oh, sorry, I am not supposed to say that.
So what did that command do?
You guys can embellish, you can say something else too if you want. This is just a prompt for you. So it created all these wheels. And we can, if you didn't know this already, wheels are just zip files. So you can go in here and, so let's make another little temporary directory and unzip one of these wheels. So like, let's unzip the NumPy wheel and see, oops, sorry, yeah, it should be, yeah, we need to do ... NumPy, blah, blah, blah. Okay, so wow, bam, it did a bunch of stuff. So this is what the contents of the NumPy wheel actually look like. There's the dist info directory, which contains a bunch of stuff like the metadata. So if we go and look in, NumPy dash 1.7.3 .dist-info metadata, we can see this contains what the what the requirements for the NumPy package are. It lists these other requirements. These are just taken from the Conda package. It lists, all the license and a bunch of other stuff. And you can go in there and mess around with other things. Note that there's a bin directory, and then which kind of mirrors the Unix file-like structure, the file structure. There's also the NumPy module directory. So if you ls NumPy here, you'd see what you would be able to import from NumPy. And yeah, so like if you wanted to install this wheel, you would need to build out all of those other little you'd need to install all of those dependent wheels. And as we saw, this contained like a lot of really, really weird stuff, like a wheel for Python, right? So that's not great, right? That kind of sucks. So, oh, yeah, oops, there's my extra shell. So, right, clearly Conda-press is doing too much work in this case, right? We went out, we tried to build a wheel, we got way more than we bargained for, and that's not good. So it would be great if we could skip building Python and building like all of the other Python dependencies, right? Because presumably those are also pip installable, or we could build wheels for those things independently. And like we have these things showing up in metadata that we like can't possibly, or we ought not go and put on PyPI. Like maybe there shouldn't be like a C runtime on PyPI. Like just, I'm gonna throw that out there. Maybe there should be, but like, it's kind of weird to have it there and have pip manage that. So, because that's not really what pip's goal is necessarily. So, Conda-press is here to protect you. Okay. Oh, shoot, I missed it. Okay. Well, let's go back. So let's go up one directory and do rm-r star, because we're living on the edge. And let's add, so here was our previous command, and let's just add another command line option called skip Python. That will hopefully help us skip all of the Python stuff. And we'll sit here and watch this because it's kind of cool. So this right now it's building the wheel for the runtime, because Python, this is NumPy links to the runtime independently of linking it through Python itself. If we scroll up here, if I can scroll up here, see we're skipping things like readline and TK, so we're skipping these dependencies of Python, which is nice. We're still building OpenBLOS because NumPy depends on OpenBLOS, and we're skipping Python itself. And bam, that only took 30 seconds to build a NumPy wheel from the existing Conda-forge packages, which is like a huge win in a lot of cases. Now, you can see it still depends on libg-fortran and libgcc and BLOS, but this is a much smaller, more manageable set of packages. So, but does this actually work, right? That's the big question. So let's go over to another terminal, and we'll just say, because we're really living on the edge here, we'll say virtual env cp test. So we're going to make a virtual environment to test this in. And stop me if you have any questions. And now, because we're really, really bold, we're going to start up bash. Okay. Sorry, little inside joke, but we're starting up bash, and we're going to not have tab completion anymore, which sucks. And source env bin activate, is that right? Such like a, yeah, wow. Yeah, activate, right. No such file or directory. Oh, CP test, that's right. I changed it in my notes, cool. All right, so now we're in this new virtual environment. We can say which Python, and it's the right Python. And we can do pip install, what is it? home/cp temp and star.wheel. So we're just going to grab all of the wheels we just created in our last command. It's going to install them. Oh no, it was already satisfied, so that's not good. So let's exit out of bash and do this again. CP test. Let's make a new virtual environment. Make a new virtual environment. Bash, and then source activate. It's going to be the right Python, and we'll pip install these wheels. It's going to go through and install them. Well, and that's definitely the first battle in any version of setting up a new virtual environment. Let's go ahead and start up Python, and we will import NumPy as NP because we're not animals, and do np.arange or something. A range of 6, because that's a good number. Our 30-second wheel for NumPy actually worked and is installable in a complete new environment. So that's that. So let's go back to the other terminal and say make a little temporary directory again, and moving on to the next part of my notes, which are definitely missing. Cool. But I think I knew what I wanted to do, which was just unzip the NumPy piece again and just sort of show you that it hasn't really changed. It's still basically the same thing. We got rid of some of the dependencies because we're not really depending on Python anymore. So those got filtered out, and that made this installable again as well. Any questions? criticisms, yeah.
Can you show us that the blast actually works in your new installation?
Can I show you that BLAS actually works? That's a great question. So what should I do for BLAS? What's a good BLAS example?
Multiplication, right?
It works anyway, even without
Ah, yeah.
Yeah, so it works anyway. So the
show config, yeah.
what?
np.show underline config.
Show. Oh, it's a function. Fancy. Is this what you wanted to see? Does this prove it to you? Or should we actually run some linear algebra code? I don't have to do that? I don't have to do linear algebra on stage? Yeah, that's true. That's cool. Yeah. It does say MKL. Wow, interesting. We're learning so much here. Listen, it's 0.0.6. I'm not claiming it's perfect. I'm claiming that it works. Okay, so what is...
Don't go out and do LDD on the SL.
Oh yeah, that's true. That's true. So like, but we need to do it in the in the virtual environment space. So like CD or like LDD. Sorry. Or let's get out of Bash because that's frustrating. Yeah, CP test, and then what is it? It's like lib Python 3.7 site packages. God, you just gotta love Python packaging.
/core.
/core.
/ underline. Underline multi-array. Yeah, that one. The bottom one.
Wow, you really gotta love. You just really gotta love all of this stuff, right? Like it's amazing. So where is it? What is it? It's linking to CBLAS right here. Yeah, it is.
It's linking to the one in the.
It's linking to the one in the virtual environment. So, voila, that was done correctly. Thank you, Maddie and Ralph and Francesca for like helping me through this. Okay. Let's go back to the slides, I guess. That's the next step. Whoa. But
Now I have a bunch of wheels. I can't upload to PyData. Cool.
I would say the last one is ellipsis, but I don't know. All right, so let's go through some terrible terminology. I didn't make this up, so I'm not going to own it. I'm going to blame other people. But we have built skinny wheels so far. Okay, that's what they're called, unfortunately. Each skinny wheel basically only contains the package that it purports to, that is that name. So like, if you have NumPy, it only contains NumPy. So you can, if you want to think of these, this is kind of like a road bike. It can go fast in ideal conditions. It's small, it's lean. There are fat wheels, which are what most people want. These include all of the dependencies that can't easily be found elsewhere. Now that's a very nebulous concept that we've tried to formalize in Conda-press with some of these options like skip Python. For example, the shared libraries of their dependencies that aren't found in other Python packages, because you know that, I guess. So like, in analogy to a cruiser, a fat wheel will get you there without a lot of extra gears. So they're going to be bigger, but they might be slower to install, etc. So don't worry, we are here to protect you from the terrible secret of wheels. And back to the terminal, I guess. Okay, so let's go back down one and arm-r star, because that's how we roll. And Conda-press has another tool that we can use to take many wheels and turn them into one wheel. So we use this merge tool. And this is a general tool, so you could go grab wheels off of PyPI right now and merge them together if you I don't know, had nothing better to do, I guess. And then we're just going to say output as the existing wheel. And we'll go ahead and whoops. I removed them all. That's cool. Yeah, because I just did the rm-r star because we were living on the edge. Nice. Cool. Let's just make them again. It only took a few seconds, right? So not a big deal. And then we'll go back to our merge version. I probably just could have skipped it, but basically merge, all it does is it looks at all the metadata, figures out which one should be the top one, so the one that you want it to be named by, because wheels have this property of a top level. And then this will just go ahead and combine all of the files together in kind of a dumb way. So if there's like multiple files with the same name, they'll just overwrite each other. Hopefully they have the same hash value, which would be good. So, okay, so let's do the merge utility. So again, this just reads in all of the wheels and then starts writing out these files. It actually takes an annoying amount of time for what it's doing, but it does in effect work, and we'll see this in a moment. So
what does this number means? Iterations per second?
Yeah, this is iterations per second. This just uses this library called TQDM. It's pretty great. Yeah, Marius turned me onto it. So like, you literally just wrap it around the like antecedent of any for loop, and you get that bar. Yeah. Cool. So like, we still have the other wheels around, but if we cd into t again, whoops, mk-dir t, and then we cd into that, and then we unzip the wheel again, you'll see like now the wheel has BLOS in it and all this other junk, and it still just retains the NumPy. It still only retains like the NumPy metadata. And if we go and look at the requirements of the NumPy metadata, it's basically nothing because everything is contained in this wheel. Cool. Yeah, you thought I was just showing you metadata for nothing. No, this was a learning opportunity you have taken. And if you look in lib, you can see all of the other things that were in that wheel. So this is a fully redistributable single wheel that has all of NumPy. We could have done this from the start because, why have to do 2 commands when you can do 1? So if we did like time, and then in the normal Conda-press, if we had just passed in fatten to this, it would create a fat wheel. So it would basically do the merge immediately after. Not a big deal. Merge is just an extra tool. So let's go back. Okay, so how does all this work? I did say that I would tell you how it all worked in the abstract. There's basically only 4 files in Conda-press. It's written in conch, as you can see by the XSH things. And there's really only 2 classes of any note in this. There's something that represents Conda artifacts, which is the artifact info package, or artifact info class. And so that is a read-only version of representation of Conda packages. And then there is a wheel class that lives in the wheel file, because, names. And that's a read-write version of wheels. So you can read in a wheel and write it back out, or read in multiple wheels, put them in a list, write them back out. And it's not very big, excessive animation inserted.
Not huge.
Not huge, there we go, right? So it's less than 2,000 lines of code. It's maniacal and evil probably, but there it is. Thank you. All right, so there are some disclosures to make about the current state of the world, and especially in terms of fat wheels. So you can overwrite files. I mentioned that already. So if both NumPy and SciPy contain open BLOS, then both open BLOSs will be written to disk, right? So because we're mirroring a Unix file system, okay. This is actually a pretty common case, right? Because we saw that runtimes were showing up anytime we linked in a C library. And then...
Gross.
Gross, yeah, it's gross. I agree, it's gross. But in fact, it's actually kind of the way that wheels and pip work right now. So it's not considerably grosser than the state of the world. And if you build on the same infrastructure, all of those files, shared objects that you're you're overwriting, they're all ABI compatible with one another. So that's the big difficulty here, is like, how do you make sure that things are ABI and API compatible? And if you're doing it all from the same compatibility layer, then it all just works. And if you're not, that sucks, and I'm sorry. And that's probably a problem for users, but at least you have a wheel right now. And Conda-Forge does a ton of work on making sure things are ABI compatible. So like, don't underestimate that. Another disclosure is that there are namespace differences. So the names for packages on PyPI are not the same as names for packages on Conda-Forge. So that is problematic, and there probably needs to be a big old global mapping between these two things so that you can resolve them. In fact, this mapping actually exists, but not in a collated way. So like, all the Conda-Forge feedstocks that come from PyPI have this information. You just need a tool to go and roll through them and build that mapping for you, and possibly with some user, like human annotation. Yeah, that's just got to happen. Prefix substitution issues. This is another fascinating part of this, so in my opinion.
My package depends on the environment's runtime prefix. Conda rewrites this for us on install. Pip install star wheel does not. So Conda-press can't work.
Gil, I'm so glad you brought that point up. Yeah, I'm just thrilled that you brought that point up. So Conda-press actually does a degree of redirection for us already. In particular, like, let's look at f2py. Does anyone not know what f2py is? All right, so no shame. It lives in NumPy. It's a binary. It translates Fortran to Python. Cool, we're good. Fortran 77, I believe, not 90. So in the NumPy wheel that we created, there's a bin /f2py. That's the original script that comes in the Conda package. But Conda-press writes a NumPy -1.7.3.data scripts f2py. And pip will go in and replace the one in scripts, or the one from bin with the one in scripts. Okay, so it replaces the second one with the first one because like that's how wheels work apparently. All right, time for a shell. So like now if we do, let's just look at what these are. That's the whole point of the shell here. So if we look at f2py, sorry, I should be in T. Did I? Oh, shoot. Sorry. CD T. And then unzip this thing again. And if we do less bin f2py, see, it's got this like pretty crazy initial statement for like how to execute, and it basically is just importing NumPy and then executing it. That's kind of, and it's got all this stuff from the Anaconda distribution that we don't actually care about anymore, or like a prefix reference. This gets replaced with the one that's in NumPy, it's data, scripts f2py. And so Conda-press is writing this terrible piece of bash, which does a redirection into the current environment, right? So it's going and looking up for the source name of the file, stripping out a couple of things, finding where the real f2py lives in our local environment, and then execing that file from instead. All right, using a process substitution. So we already do actually a bunch of like prefix resolution dynamically at runtime in Conda-press because that's the only way it can work because wheels are static. Cool, we're good, we're on board. We could extend this to do like other runtime wrappers for prefix redirection if we needed to, an environment setting, including like just screw it, like inject code into init.py and like you're good to go, right? Like that's all you need. Like that would work and it would solve a lot of problems here. We have a dynamic language. We can get around any of these prefix substitution issues. It's just a matter of knowing what they are. All right. All right, well, what do you guys want? What package should I try to make a wheel out of right now?
PyTable.
PyMC.
This is a good package, everything.
PyMC?
Yeah.
Yeah, right? I think PyMC was the first one. Let's just try it. It'll probably fail, and that'll be great. So let's just go up here. So here's how I would do it, because I want to be very specific. So I would say, I would actually go to, let's just create come on, control new, well, whatever, anaconda.org. So I would go here, and I would say, I would search PyMC and see what like the most recent 3.7 version is.
It has a 3 on it.
What?
The name actually has a 3 on it as well.
Yeah. Oh, nice. Oh, it's a no arch package. Come on, that's easy. Is there another one?
Rust.
Rust? Do we have a Rust package?
Well, there's
We do have
Yes.
We do have a Rust package. All right. So like, yeah. Let's just do this. And I would say, maybe we'll get back to PyMC in a moment, because no arch packages are really just a copy from. So that's that. I don't even know what Rust depends on. Probably not a lot. But you know what? We can do this multiple times. Let's just have fun, right? How much time do I have? 10 minutes or 8 minutes. Feel free to ask questions and things too. Like, it's fine. Kind of question
I
time.
want to use Conda-press, but I want to be able to pip install it.
Yeah. Yeah, I mean, I feel that. Yeah, so the reason you can't pip install Conda-press yet is actually, I want that vision statement that we got back to be complete. So I want Conda-press to be the alpha tester for getting wheels built on Conda Forge and then pushed up to PyPI. At that point, Conda-press will be pip installable. All right. All right, and it looks like we've built a Rust package, more or less.
Does this mean that you now have a rusty wheel?
I do. Oh, wow. I have a rusty wheel. I rolled into that one. Okay, well, let's go back and do, this is actually a good use case. So PyMC 3, where was it? PyMC 3? Or is it just PyMC when you...
Yeah, it's PyMC 3.
It's PyMC 3. Wait, so what's the PyMC package?
Real packages version in their name.
Yeah, real packages put their major version in their name. That's why I've never done anything real. Like I can't even copy from the browser without opening up the... I cannot hear the snark, so... Oh yeah, Conda, activate CP. And okay, let's go check in on Rust. I guess it's actually writing the merged wheel now. So yeah, you can do esoteric, stupid things like this, where you... Oh, okay, right there, perfect. We created a PyMC wheel. You can see it because we skipped Python. Like it's skipping a lot of stuff. Like it's skipping pandas, it's skipping H5Py, it's skipping all the stuff that it knows that it can get from other places, or that in theory should have other Python wheels available or other Python packages available.
Rust depends on the piano?
Rust depends on Theano. We're not getting into no, sorry. That's the PyMC browser or terminal. Yeah, Rust doesn't depend on Theano. That would be fascinating. Wow, good one, Maddie. So why don't we go and look at this, right? SMKdir T. Oh, why can't I make? Wow. You know, I expected a lot of errors, but not that one. Nice. Cool. Should I just like delete my content?
One directory to that rm-r thing.
Yeah, I think Gil is suggesting what is it? rm cd dot and rm. You're right. It's wrong. It's wrong. It's wrong. It's that. All right. All right. I think we're having fun now. Finally.
Serious question.
Serious question. Oh no. Okay.
So these wheels are being created against the Conda-forge ABI surfaces, right?
Yeah.
So are those necessarily compatible with pre-installed PyPI wheels?
Okay, so the question is, these are being made from Conda-forge, the Conda-forge ABI. Are those compatible with other things on PyPI? Great question. There's sort of two answers to that. So one, this can take any channel. So it's not just Conda-forge or defaults. You can pass in any channel. I didn't show that off. Whatever. The second thing is that Conda-forge at least builds against a very old ABI, and if you're running on many Linux, most many Linux 1 packages and this and Conda-forge are compatible ABI wise, or they should be. They might not be in all cases. I'm not going to guarantee that per se. The other thing to note is that this works on more than just the many Linux spec, right? Conda-press, our test suite runs on Linux, Mac, and Windows. You can build wheels for all of those systems. You could build wheels for ARM and PowerPC if you wanted to using this, because that's what Conda-press does, or Conda-forge builds packages for those architectures. So this is an entryway to building wheels for all platforms with the same command. That's the real power. Yes, Maddie.
There's nothing really platform specific within Conda-press itself, right?
Nothing platform specific in Conda-press itself, except for the fact that pip wheels on Windows get installed in a weird way, and Windows has some slight differences.
So you couldn't actually can you build a Windows wheel in your Linux environment here?
So can I, great segue to my last slide. So I want to thank Marcello. I also want to call out, please send help for this project. It definitely needs work. Right now, to answer your question, we need to be on the same platform. So there's a couple of caveats, mostly the RPath rewriting. We're not doing that in a platform independent way. So there are tools like Leaf that allow you to do dynamic library RPath rewriting on other platforms than so you could rewrite on Linux a DLL, or on Windows you could rewrite an SO's RPath. I've never used that ABI. Conda does, and they use it all the time, but I'm too lazy to figure that out, so someone else can. And that would be a great place to send help. The other big issue is that for some wacky reason, even though these things are just zip files, pip does not respect unzipping symlinks. And so to get around this, we have to do a hard copy of every symlinked file in our wheel. It's totally stupid. There's an issue opened about it. If someone could please fix that, that would be amazing. Yeah, 5 minutes. Or even, I thought I was out of time, but that's great. So we could dramatically decrease file size. We need a little bit of help integrating this into Conda Smithy. Marcello's doing some of that work, but I'm sure he would love help. We need help integrating into the warehouse. I know that there is a GitHub action to do this now, to push to the warehouse, but again, still need help there. And I think that is it. So thank you very much, everybody.